Hey there, this is Brom Bresenham. I've just finished Week 7 of rebuilding Axor the Mighty in the Godot Engine, and I've got a short and sweet update for you. I spent most of my time working on building the game status bar. This includes creating the node-based layout in Godot, prepping the art my contractors delivered, adjusting the layout design, and creating a few simple additional icons. On the left is the info panel with the player's personal high score, the current level and round, and the power-up prize that the player will receive after winning the current round of combat. Next to that are the health and energy bars. To the right of the bars are counters for rampage, score, and gold. At the very right is the game settings button. The health and energy bars, sizes, and fill levels can be adjusted via editor properties tied to a tool script. The width of one cell is 83 pixels in the source art. The bar images are set to aspect fit, which means increasing the width of space filler components at the end of the bar by 83 pixels, shifts the bars and/or the frame 83 pixels to the left, no matter what the display size actually is. While I was building this UI, I released two small updates to my GameGUI Godot UI plugin. The most significant is that the GGH box and GGV box now have a content alignment property. A GGH box can align its content as a whole to the left, center, or right, and a GGV box can align it to the top, center, or bottom. The GameGUI plugin is available on my GitHub at the address shown here. Related to this UI, I also added some new filters to my console-based image editing program called Vimage, which uses Vim-style commands to edit images. It's available for Windows, Mac, and Linux at the address shown here. I have another video on this channel that demos Vimage in more detail, so I'll just describe the new filters. Several times recently, I've wanted to add a gold tint to a piece of artwork. It's not as easy as simply adding a yellow tint. If the original image is bright colors and dark colors, we don't want the result to be bright yellows and dark yellows. Instead, we want bright yellows and bright oranges. In the end, it was very simple to accomplish. For each pixel, I essentially just map its value, or brightness, to a three-part linear gradient. A pixel that's 66% to 100% bright is interpolated to a yellow to white gradient. 33% to 66% brightness is mapped to a orange to yellow gradient. And the lower 33% brightness is mapped to a black to orange gradient. At first, I took the max of the red, green, and blue pixel components as the brightness. That's straight from the established RGB to HSV, hue, saturation, value, conversion formula. But then I realized it gave an overly bright result in many cases, as bright blue and bright white, for instance, both end up as pure white. Still, I kept that filter and called it bright gold. In Vimage, you can type :filter bright gold to apply it. I then added a second gold filter that uses a more sophisticated blend of red, green, and blue components to determine a pixel's brightness: 30% red, 58% green, and 11% blue, the same blending formula that Acorn Paint uses to convert color to grayscale. In Vimage, you can type :filter gold to apply it. To round things off, because I was already doing the work of grayscale conversion, I added a grayscale conversion filter as well: :filter gray. The energy bar graphic was the catalyst for creating these gold filters. The artist team had created a red health bar and an orange energy bar, I decided I wanted a yellow energy bar instead. Not just yellow, gold. Applying the bright gold filter to the red health bar and the regular gold filter to the orangish energy bar icon gave me exactly the results I was hoping for. I'll finish off the video by editing together this video's thumbnail background using Vimage. Alright, that's a wrap on week 7. Catch you later.